All right, this is FRQ 3. The problem gives us a table. I would expect to see a table on this test this year. And the table is a derivative table. Okay, so this is a rate. And just remember that the area under a rate curve is going to be some sort of amount. And who knows if that's going to play a role in this. And then they give you a little information. Here is a value for the actual function and not the derivative. So f of 0 is 20. And this is going to be important here. Every value of the derivative, even in between, like at 0.5, has to be between 0 and 7. Okay, it can't be negative, and it can't be higher than 7. And that's for the derivative on this closed interval. Okay, and they tell us that the second derivative is continuous. Okay, the first thing is use a midpoint Riemann sum with 3 subintervals, so that's key, of equal length, and we're going to use this to approximate f of 6. Okay, and just to give you an idea of what we're doing, I just quickly plotted the points. You do not need to do this. It's just nice to have a visual representation of this. Okay, this is the rate curve, the derivative curve. And since we're breaking into 3 subintervals, here's one rectangle, a second one, and a third. Okay, the base of each rectangle is 2. And it says to use a midpoint Riemann sum, and so I've chosen the midpoint for the y value. Okay, and so their work on this one looks like this. Now what we're finding is the area under that rate curve, so the integral from 0 to 6, and it's approximately the areas of all the rectangles added up. Okay, but then what they're telling you is they want you to use this to approximate f of 6. Okay, and so we look at this integral right here, and we realize, well, this would be the antiderivative of f prime, so f evaluated upper limit minus lower limit. So it's equivalent to that. Okay, and what we're looking for is this right here. So I would add this to this side. And this is our approximation, the 20.2, and we were given that f of 0 was 20. Okay, and note their scoring. 1 point for the midpoint sum, 1 point for the fundamental theorem part 2, and finally 1 for the answer. Okay, and then part B. Determine whether this approximation could be so far off that it's actually 70. And the idea is this. If we look back at here, the area under here, well, this is just approximate. We don't know the value of this y value at whatever that is, like 4.5 or something. Maybe it's 100. And so the curve comes down and then goes way, way up, and you have a tremendous amount of area under this curve. But then we looked back and they told us that the highest f prime could ever be was 7. Okay, and so no matter where I plot it in here, I'm not plotting points higher than 7. And so the maximum rectangle you could make would have a base of 6 and a height of 7. Okay, and that value would give you an area under the curve of 42. Okay, and then doing what we did up here, you'd add f of 0 plus 42 to get 62. So the biggest f of 6 would be 62 and not 70. Okay, and then once again, we look at their points awarded. Part C. This is a rather quick one here. Just the integral from 2 to 4 of f double prime. Okay, and we just have to glance at their work. Okay, we're anti-deriving f, the second derivative, and we get the first derivative, evaluated at upper limit minus lower. Okay, and we just take the values from the table, 1.7 for f of 4 and 2 for f of 2, and note the 2 points for that one. Okay, and then finally, I'm going to use L'Hopital's here. Okay, this initially could be a tricky problem because at times when you see a limit problem like this, you're thinking of the limit definition of a derivative. And so go back and look at that, refamiliarize yourself. It's one of the first things we did this year. But this actually isn't. This is going to be a L'Hopital's problem. Okay, and so when we look at their work, we see that And this is how they want you to express L'Hopital's. They don't want to see you write equals 0 over 0, but the top limit is 0, because remember we're given that f of 0 is 20. 20 times e to the 0 is 20, and so we do get 0 there. And likewise on the bottom, we get 0. Okay, and so they want you to see that they want you to say you're using L'Hopital's. Don't abbreviate LH. Okay, and L'Hopital says that this limit, the original one we're looking for, is equivalent to the limit of the, and now remember this is the derivative of the top, and that's the derivative of the bottom. It's not the quotient rule. Okay, and then we look at f prime of 0 from the table, and that's 4. E to the 0 is just 1, so 4 minus 20, and then f prime of 0 once again is 4, and we see their square. Good luck.